Hello, ladies and gentlemen. I hope you're all doing well. Root Beer here with question number 22 on our grade 8 Gauss paper from the year 2010. Let's dive in and take a look here. So question 22, the values of R, S, T, and U are 2, 3, 4, and 5, but not necessarily in that order. But each number is paired to a letter and so on. What is the largest possible value of R times S plus U times R plus T times R? Now I'm noticing R is in each of them. So this makes me think I could factor some things out. So let's write down this expression. We've got R times S. I think they're just trying to be sneaky putting the U first there. But really this is R times S plus T plus U here. R times S plus T plus U. Okay. So if I want to make this as big as possible, well, I should probably try and make these two expressions, R and S plus T plus U, as big as possible. Now, how do we go about doing that? Okay. Which one should we place more emphasis on? Could I take something like R is 2 and then see what the sum is? Now, the interesting thing here is we don't have to reason our way through it. We could just very quickly make a chart, because as soon as I pick R, well, the other three numbers go to S, T, and U, and I actually don't care what order, because they're all getting added up anyway. So if R is 2, well, S could be 3, S could be 4, S could be 5, but S, T, and U will be 3, 4, and 5, just not necessarily in that order. And we'll have a sum of 12. And if we've got R is 3, then we'll have 2 plus 4 plus 5, so the sum will be 11. And if R is 4, then we'll have 10. 2 plus 3 plus 5, the numbers that are left over. And if R is 5, we'll have 9. And so now what is this product? Well, we only have the 4 cases to work with. 2 times 12, 24. 3 times 11 is going to be 33. 4 times 10 is 40. And 9 times 5 is 45. Okay? So, there we go. Our answer is going to be 45. That's as big as we can make it. Now, I mentioned we don't have to reason our way through this. But there is some reasoning that comes up every once in a while on things like the Gauss or the Pascal when we're trying to make things as big as possible when we have, one might call them constraints. Okay? If you've got a product of two things and you want to make that as big as possible, but the two things always have to add up to the same number, this happens a lot, or if you've got a sum that you want to make as big as possible, but the two things you're adding up have to have a constant product, there are certain sort of reasoning tricks that you can learn. So if I've got two things that add to the same number, but I want to make their product big, my idea is that I want the numbers that I'm adding up to be as similar as possible, as close together as possible. Just like if I want the product to be small, I want the numbers to be far away. And we can actually see this taking place in this question. The smallest product is where 2 and 12 are as far away as we can get, whereas the biggest product is 5 and 9 being really close together. Now, as for why this works, well, you can talk about parabolas when you hit grade 10. You can talk about inequalities if you want to study them, or you can talk about calculus when you get to grade 12, but it's just a helpful little guiding principle. So I noticed that the two things I'm adding up, R and S plus T plus U, they have a constant sum. It's 2 plus 3 plus 4 plus 5, which is going to be 14. So we do have a constant sum. We're just breaking it up into two parts, and then we're going to multiply them together. And again, the guiding principle that we see for these sorts of things, if we want a big product, the numbers should be close together. As close as we can make them, well, that means R has to be as big as possible to try and catch up to the other three numbers being added together. So that's a way you can sort of reason through it, but there's only 4 cases. I think it's much faster just to draw the little chart. Okay, so what have we got here? 45, that's B. So the answer to 22 is going to be B. And we'll flip the page to get ready for question number 23. I will see you for that in the next video shortly.